Alright, so here's a very interesting problem, and I'm going to go ahead and highlight some information as we read through the problem. Suppose a square sheet of aluminum. So we know that we're starting out with something that's the same dimension on all four sides. A square sheet of aluminum has dimensions as given by the illustration, and a welder decides to cut out of each corner a square with side length C equals 5 inches. So we have, here we have C, and that dimension is 5 inches. The welder then folds up the sides to form a rectangular container with no top and a volume of 80 cubic inches. Two questions: what is the side length x of the new rectangle, and what was the area of the original sheet of aluminum? So I'm going to go ahead and bring up a little the dimensions here for C. Fill those in, and those are equal to 5 inches there. And then also a little sketch of the folded up box. We're taking this flat sheet, cutting out the corners, folding it up into a little sort of a tray. And let's go ahead and dimension this drawing with what we know. We know our height now is that 5 inches. And then we have two dimensions. We can call those maybe length and width, or whatever we're going to call that, depth maybe, width and depth or something like that. Our two x values that we need to solve for, and we know that those are both the same, right, because it's a square. So let's start thinking about what we have to do here. Our first challenge is to figure out this side length, and we sort of have to back into this. We know our volume and we know our height, so let's start with what we know about how to calculate a volume, and we'll start with that right down here. A volume of a rectangular prism like this, or a tray, is going to be length times width times height. That's how we usually see that. And in this case, we know the height is 5 inches, and we know that the length and the width are both the same value, which are x. We could rewrite that as equals x times 5. And x times x, we can rewrite that or think of that as x squared, can't we? So x squared times 5, that's our volume. The other thing we know about our volume is that it's given. We know that it's 80 cubic inches. So now let's rewrite this equation. Usually we see the coefficient before the variable term, don't we, or in the term. So let's write that as 5x squared is equal to 80, and that's what we know. Solve for x here, we can go on to say, well, let's divide both sides by 5. 80 divided by 5, so we know now that x squared is equal to 16. If we take the square root of both sides there, to find x is equal to 4. So there we go. There's the first part of our problem. So now we know that this value right here, this x value, is equal to 4. We know that our C is equal to 5, so let's put another 5 over here, and let's put another 5 down here and fill in our x value. And remind ourselves once more, what's the second part of this question? What was the area of the original sheet of aluminum? So now we have a sheet which is 5 inches plus 4 inches plus another 5, so that equals what? 14. So now we started. I'm going to bring that maybe right over here. Our original sheet, the total dimension across the top was 14 inches. Same with the sides, right? Our total dimension down that right side is 14 inches. How do we calculate the area of that original square? We just take 14 times 14, right? That's our length times our width. And 14 times 14 is going to give us 196. Those were all of our dimensions in this case are inches, aren't they? So I should come back and relabel this. Our x is actually equal to 4, not just 4, it's 4 inches. And since in our area problem up here we have 14 inches times 14 inches, our final area dimension is 196 We can say inches squared or square inches. And that is our final answer. Here is our first final answer. So this is part 1, and this is part 2. I hope that's helpful.